Welcome to Pre-Calculus and my particular lesson on problem number 3 of the homework. And I use voices like that. It sounds better when I'm helping you in a radio voice or something. Here is number 3. And the way I would tackle it is first read the directions carefully because I didn't do that this morning. Somebody came in, asked for help on this, and I said, hey, let's put it in your calculator. Got all excited. And I even read the directions I thought carefully because it says in here, this table is male and female populations in a certain county employed in the workforce in certain years since 1989. And since 1989 is important because it actually indicates that our times will be 0 will be 1989 because 1989 is 0 years since. And then each year after that is how many years since 1989. So they're very low numbers. Gracias, señor. When you're doing data like this, graphing, and using the actual year is not a good idea because if you think about it, it puts you on like way out on the right of the x-axis, like crazy far out there, like 1,989 points to the right. So we tend to use like the very first year of data, we call that year 0, and then work your way up from there. Good. And this is indicating that by saying since. So we put the data in our computer, and we got a regression equation, we were feeling good, put it in there, and it says wrong, incorrect, red box with x's in it. And that, as a math teacher, it hurts. Because I don't like to be wrong. But I was really wrong. Because the directions say, use the 1989 and 1995 data to complete the slopes. Oh, just 2 points. That's different. So we're only looking at women, right? This is the equation to represent women's employment statistics is y equals. And 1989 is 31.9 and 1995 is 58.6 or 4 and 58.4. That means we're really just doing a problem of finding the equation between 2 points, something we've done before. And the first point is going to be 1989, 31.9, but we're not going to use 1989. We're actually going to use 0. Okay, so this is, I want to do like the slope, so that I can put that in my y equals mx plus b. That's the first thing I'm going to take on. And the slope is change in y over change in x. So my two y values are 58.4 and 31.9. So the first thing you do is 58.4 minus 31.9, 31.9. So that's your numerator. And then your denominator is, you can think of it as 1995 or 1989, but really I want to think of it as, what is that, 6 and 0. However you want to go about it. I could do 6 minus 0 because I'm thinking of 6 years after 1989 is 1995, and I'm thinking 1989 is 0. That would be fine. Or in this particular case, since you're doing, it's just the x elapsed from, the x on the right minus the x on the left, you could just do 1995 minus 1989. In this particular instance, it doesn't matter. You get 6 either way you do it. Okay. Slope is the ratio of those two. It's 26.5. That's the rise over the run, and you want to make sure you went the right direction. Like I subtracted y's right minus left, and then the x is also right minus left. And I divide the two to get the slope. So there's my slope, 4.4166666. Oh my word, what a great number. It's the same thing as a what is it, 53/6 or something like that. It's okay. In your answers it says use integers or decimals, round to the nearest hundredth as needed. So as our slope comes up, we are going to round to 4.42 when the time comes. Okay? So as I get my slope, now do you remember the rest of the equation is that y minus y1 equals m times x minus x1, and then you kind of work from there. That's what we're shooting for in this particular equation. And so if I were to choose how to do this, I would be doing like y. So I'll do it on here just to type. And actually I can use Word too. I have that up and running. You want to see it on Word? Make it bigger. Big. Big, big. The reason I say that big all the time is Graham loves to say things are big because he's a big boy. When you're 2 years old, you start almost 3. He talks about how big he is all the time. 4.42, right? Is that what we're going to use? 4.42. Sound good? Okay, that's what we got for our slope. rounded to 2 decimal places per the instructions, and then times x minus x1. Now I'm using the computer here to kind of give you some bigger perspective. The x1 and y1 are a point that you choose on there. And one of the points is either 1989 and it's 31-ish%. So if I go up there and show you, let's see, this is 119 and 31%, or it's 1995 and it's 58%. Thing is though, you need to, using the year as 0 for 89 and 6 for 95, it's going to come in handy. So do y minus, let's do 95, year 1995. So y minus, the y in that year, remember, was 58.4. Okay, y minus 58.4 equals, now there's some danger going on here. 4.4, this is, I'm actually highlighting an error that's going to come up in another instance that somebody brought to me that we fixed, so watch out. I'm going to show you something. And if you do x minus x1, and our x1, isn't that the same y, or the x that goes with 58.4, that would be 6, because we're doing 6 years after 1989. Okay, so far so good. And if y'all want to write it in there, it asks in the problem to write it as y equals yada yada yada. Okay, so let's do it. So I'm going to solve for y. Y equals, it's 4.42. And if you guys are looking, there's something wrong taking place even now. In about 2 seconds, I'm going to mess up on purpose, but I'm see if you can notice it. Okay, I'm going to, well, actually, darn it, I didn't mean to mess up twice. I haven't. Am I screwing up again? Golly. Hang on, I'm almost there. At least let me know what I'm trying to predict when I'm going to screw up. Okay, and then a minus. All right, I'm going to do 4.42 times 6, because I got to distribute that, right? 4.42 distributed. So if I do that little doohickey, let's get out of alpha lock. Okay. Hey, stop it. So 4.42. That's not good. 4.42 times 6, correct? Hit enter. 26.52. Okay, so 26.52, and we still have the plus 58.4. Okay, everything good so far? I'm going to add those together. Negative 26.52 and 58.4. I'm going to do a little trickery here. I'm going to say 58.4 minus 26.2 has the same effect. Okay, should be positive 31.88. Okay, this is what I think I'm going to type. Do you think the computer will like it? Okay, and that number is, what was it, 31.88? Okay. You're watching at the edge of your seats. Will he get the green check mark of approval, or the big, just absolutely debilitating X, the one that crushes your soul, makes you just feel little, small? Okay, here we go.
Wait, have you done this before?
Have I done this before? This particular problem, no, but I think I'm screwing up.
It should be 31.9, I believe.
You think 31.9? Because it says round it? Okay. Let's do that. Let's do that. It says near to the nearest hundredth. Do you think my 31.88 would be okay? Because that'd be hundredth. Maybe, yes. Why maybe? I'm open to this because really I am. I'm just going with it. Okay. Let's just put it in there because this is what it's all about. Watching and waiting and getting excited. Here goes. 4.42. I already think I screwed this up, and then you guys are going to point out other errors. Good grief. I have very low faith in this. What's that? If you use a capital X, it won't work. That's another one too. Oh no! 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 Say it ain't so. Knock knock.
Nathan Gooding here.
Nathan Gooding, yeah. We always got. He is given a small jewel. Look at that. It's glistening in the sunlight.
Congratulations.
Oh no. Now we have the least popular person in the room, Nathan. All right. To find, unless you're riding with him to school, that's another story. So to find the slope, you find the change. Then it tells me what to do. It says, hey, you should subtract 95, 90. I did that by changing y, subtracting. I did that. Thank you very much. Divide the y by the change in x. I did that. And it says use 1989 as x equals 0. Okay, I'm there. Darn it, what happened?
I think that since you used 1989 as 0, and that's like the y-intercept, you have to do 31.9 because that's what the point is.
So 31.9 is the actual point?
I don't know, I could be wrong.
That's a good idea. Do you want me to put in 31.9?
Sure.
So were you, Charles, you were guys, you are all suggesting this, and I said, why? Why would I do that? So, okay, 31.9. I'm with you. All right, fine. Fine. I feel so much better. I can move on today to 31. Now, that's not the only way that 31.9 can come up here. It happens another way, too. So even if you'd done all this calculation, you would have gotten 31.9 if you'd have done this one thing. If y'all had we're in statistics, you're probably harped about this. When I put in 4.42 early on, that was a problem.
You have to do.
You never, ever, ever round until you're done. Never, 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 ever round until you're done. So an internal number like that I used,
But I forget to round when I'm done.
I know,
I
and
did
then
this problem
that's,
like 3 times, and every time I was like, I did it over and over again, and it was all because I didn't round.
that's
I
it.
Just looked at the example and that's what it means, so.
Yes, and the example, it's a wonderful thing. 26.5 divided by 6 is our actual slope. So what I should use is 26.5 divided by 6. If you don't like 26.5 divided by 6, you could actually multiply the top and bottom by 2 and it'd be a little nicer. I could make that, like I said before, that would be, what, 53 over 12, if you prefer, and then you could work with it. Okay, so that would not be rounding, and if you do that, I do believe you get the 31.9. But you guys, using your smarty smarts, said, hey, isn't that the y-intercept right there, 31.88? Which hits when x equals 0. Don't we have the y-intercept when x equals 0? We do.
Oh.
So
That
smart.
was just like given to us.
You can do the calculations without rounding or use the data that you have. I love it. That's so good. Quality folks, good quality. Done with that video. Let's get cracking, huh? So I actually can't find how to stop the video, so I'll unplug my screen. There it is.